Now we're switching to using the quotient rule. With quotient rule, you'll notice you're going to see some fractions involved here. So the square root of a quotient, a divided by b, is equal to the quotient of the square roots of a and b. And of course, b cannot equal 0, because if it's 0, it's found in the denominator of the fraction, and that would make it undefined. So b cannot be 0. Notice that if you are starting with one radical symbol with the fraction a divided by b under it, you can break it apart into two separate radicals. The reverse is also true. Sometimes we're going to start with two separate radicals, and we'll find that it's better to put them both under one radical sign. So we'll be able to work this forwards and backwards after a little practice. So here are the steps to simplify. First, we're going to write the radical expression as the quotient of two radical expressions. We'll simplify the numerator and simplify the denominator. In example 1, you can see that under the square root we have the fraction 11/36. Well, if you take 11 and divide it by 36, you're not going to have a perfect square number that's recognizable. So we don't want to do that. We want to separate it using this quotient rule. So that breaks the fraction apart as square root of 11 divided by square root of 36. Now this is helpful because we know that 36 is a perfect square. It comes from 6 times 6. So we know that 6 should completely clear that radical. However, 11, the only factors of 11 are 1 and 11, so that will need to remain under the radical. This is the simplified answer. With example 2, we're starting to work with our variables. Now we have the number 216, which is divided by 8. So if it's possible to take 216 and evenly divide it by 8, then that's what we'll want to do. So 216 divided by 8 actually is 27. So that would make 27 over 1. Looking at our variables, you have to think back now. Remember all those exponent rules that we talked about? Notice how we have the base of x written in two different places. We have x to the 7th in the numerator and x squared in the denominator. So what we want to do is figure out, should x be collected in the numerator to have a positive exponent, or should it be collected in the denominator to have a positive exponent? Comparing 7 with 2, 2 obviously is smaller, so that means x squared is going to shift into the numerator and the sign of the exponent changes. So far, this is what we have. 27 collected in the numerator, and now our x to the 7th is going to be joined by x to the minus 2. Now we'll work with bases of y. Y to the 9th, y cubed. So it looks like 3 is the smaller number. This base also will be shifting into the numerator. So all 3 of our bases shifted into the numerator. That means we no longer have a fraction under the radical. So we have y to the 9th, and now y to the minus 3 is shifted into the numerator. So what this looks like now under the radical, we still have 27, but how much x do we actually have? 7 minus 2 would leave 5, so that's x to the 5th. And then for bases of y, we have 9 minus 3 would be 6. So y raised to the power of 6. Now we're ready to work with our problem. 27 is going to be divided by prime numbers. So I know 3 is a divisor. 27 divided by 3 leaves 9. 9 divided by 3 leaves 3. And 3 divided by 3 leaves 1. Since we're working with a square root problem, we want to find pairs of numbers. So 9 times 3. So under the radical, we're going to break apart 27 as the square root of 9 times the square root of 3. For our variable bases, remember, we're going to use the technique of dividing by the index of 2 because it's square root. 5 divided by 2 equals 2 remainder 1. So that tells us the exponent of 2 belongs with base of x, and exponent of 1 belongs with base of x remaining under the radical. Using that same process with our base of y, 6 then is divided by 2. That equals 3 remainder 0. So exponent of 3 for that base clears, but none of that base remains. Square root of 9 is 3. Square root 3, just copy x squared. Square root of x remains, y cubed. Let's put everything in order. So all of the terms that have cleared the radical are what we write first. So our final answer would be 3x squared y cubed multiplied by the square root of 3x, because 3 and x were remaining under the radical.